So good morning, good afternoon, good evening, wherever you are. My name is Vishnudat and we are in class number 13 of Machine Learning from Scratch course. And today's class is going to be the last class of this course. And thank you so much for your patience. So what's going on here? In today's class, we will be talking about how we can connect our entire learning, whatever we have learned in machine learning course, to computer networking. I know that there are various people from different background in this course. But today is the day of network engineers. We are going to connect machine learning and computer networking. How basically we can utilize the machine learning in computer networking or computer networks. But to understand that, we need to understand a typical enterprise network. By the way, there are multiple or different types of network like service provider network, data center network, and a typical enterprise network. So we will be talking about how we can use machine learning in a particular enterprise network. Once done, I would like to showcase you once we have a little bit understanding about the enterprise network, which I am absolutely sure that we all know. But it's my way that we should be on the same page. So starting 10-15 minutes, I will be spending that how a typical enterprise network looks like. Then we'll be talking about how we can use linear regression, which we studied in the first 10 classes or 9 classes in computer networking. And then we are going to talk about how classification in computer networking or how classification problems can be used in computer networking, right? Once done, I will be talking about the cost function. I just want to showcase how a cost function of classification problem looks like. Yesterday, I didn't showcase this to you because I thought that it is going to be too much mathematics. But in today's class, without understanding the mathematics, I just wanted to showcase that how or what a cost function looks like for classification. Then we are going to talk about what is next. Maybe you should start learning deep learning after machine learning or maybe something else. So this is the whole agenda of today's session. If you give me next 1 hour and 10 minutes, these concepts are going to be with you for a long time. Having said that, let's move to the first board where our characters are talking to each other, right? And now they are quite confident in machine learning. Rahul and Anjali knows that how machine learns. But from occupation, they are network engineers also. They have a responsibility of a complete enterprise network, right? They maintain it, they manage it, and in fact, they have created that network, right? So after learning machine learning, they would like to implement the knowledge into their network that how they can improve their network using this, one of the most interesting technology of today's time, right? But again, first, they would like to showcase you, we all, that how their entire network looks like. Once we understand their network, then we can guide them or they can guide us that how they can utilize the knowledge of machine learning. Having said that, let's see what their network look like, right? So this is a typical enterprise network. Maybe we can say that it's a network of a company named Sports India, and this company makes sporting goods, right? Cricket bat, ball, stumps, football, so many things. And the business of this company is growing like anything. First, they started with their campus network with just only one building. In the same campus in Delhi, they have another building, then the another building, and then they have connected all the building. And we all know that inside this building, the network which runs is known as local area network. Right? We can build this local area network depending on different kind of networking devices. Right? You must have heard that in LAN architecture, we can use access, we can use distribution, and we can use core switches, 3-tier architecture of Cisco. We all know about it, right? If you don't know, that is perfectly fine. But this is how these three buildings are connected. And we are utilizing switching and routing to connect all these buildings. These buildings are close together inside the same campus network. Maybe everything is inside 500 meters or 1 kilometers range, right? Now in the Delhi office, approximately 1,000 people work. We all know about the enterprise network. We all work in an enterprise, right? And every enterprise is having a network. We just go there, connect our laptop to the Wi-Fi, and then can start working there. But what do we work on, right? We all know, suppose a person who is from an HR background who is in any of this building, if you want to work, he or she should be working in a specific tool. Maybe the tool which is maintained and manages the record of all the employees, their salary, right? Number of years of experience, how many devices, and so many things, right? But the application on which this guy is working is stored on a server, right? And that server is in a centralized location, which is in Mumbai, and we call this server as a data center, right? So in data center, we have different servers, and every server might be hosting different applications, right? And these applications are used by these employees working in this campus, right? Thousands of employees. If that is the case, we have all the servers in one space or one facility, which is known as data center. You all know that when cloud comes, we move most of the servers from this place to the cloud, right? Because cloud was offering too many things, and the maintenance and management of all these servers is the responsibility of the cloud now. But many companies still have their on-site data center also, right? And Mr. Rahul company, the Sports India company, is actually having some server which they do not want to move to cloud, and that is why these servers are in their Mumbai data center, right? Most critical servers. We are talking about data center. We are talking about this campus network now. Other thing is that this company is growing really fast, and that is why they are having different branches. One of their branches is in Bangalore, where 250 people come and work. So they have rented a building there. What we call this is one of the branches of this company. Maybe Hyderabad, they have another campus where approximately 500 to 1,000 people work, right? Again, a local area network is also there. Local area network is also there. Mumbai is the data center, right? Maybe different kind of technologies are working or creating this network, data center network. You all know VXLAN is one of the technology where we are extending the VLAN. Why do we need to extend the VLAN? By the way, whatever you are seeing here, whatever I have said till yet, it is explained in very detailed manner. All the design aspects, BGP, OSPF, switching, everything, whatever you are seeing here, SD-WAN, SDXs, right? Everything is right here on the website in these simple terms. They also have a Pune location, so they have 3 branches: Pune, Hyderabad, Bangalore. They have one data center, and they have campus also, right? As simple as why I have drawn home here, because there are some employees who work from home, connect from internet, and then try to come to the data center to access all these servers. What is this guy? This guy is on internet, try to access some of the company's server, but just this company has server for external user also who are not part of this organization? Yes, absolutely. There are some servers in Mumbai data center, which is the website which hosts the website of this company, sportsindia.com, so that people around the globe, around the internet, can come to these server and can place their orders so that you can deliver them online things, right? This is how the overall network of Anjali and Rahul looks like. But now the question arises, how exactly these branches, campus network and data center connected together? So Rahul and Anjali are dependent on 2 different type of WAN services. Why we are calling them WAN services? Because you are connecting 2 things which are really far away from each other. For example, if you see Delhi and Bangalore, the distance between them is approximately 2,500 kilometers. And if you want to connect them, you cannot do that on your own. You cannot stretch a wire from Delhi to Bangalore on its own, on your own, but you can take help of some of the service providers, right? They are using service provider, maybe Airtel Jio, and they have taken their service. Maybe they have taken an MPLS service. The MPLS is actually used to connect different remote branches or campus network, right? It's a solution which is slightly costlier because it's a private solution. All these wires which you are seeing here, it is the responsibility of the service provider to lay them down between Delhi and Bangalore. And it is not you which is only connected through this MPLS network. There are multiple other customers also. And it is the beauty of MPLS that it keeps every customer separate, right? So Mr. Rahul and Anjali have taken the service of MPLS from the service provider, and they have another link, which is internet. If something happened to the MPLS, then they are going to utilize this internet link to reach to all the branches in the data center. So basically in their Delhi environment, this is their active link, this is their standby link. Everything is going over this MPLS, right? You must be wondering, Mr. Vishnu, only 2 circuits? They might be having more, but for the simplicity's sake, to explain you the complete organization, how a typical enterprise looks like this. And by the way, this block, right, whatever we are using right here, this is actually known as your wide area network. If we talk about Cisco in WAN, Cisco offers SD-WAN, software-defined WAN. In data center, Cisco offers another technology or the solution, which is known as application-centric infrastructure to connect all these servers. To connect all these branches and campus, they have SD-WAN solution, which is one scale up, which used software-defined approach to create your WAN. It is not the case that before SD-WAN there was no WAN. There was WAN, right? If we are connecting using MPLS, MPLS is that WAN. But now SD-WAN works on top of MPLS to provide some good things over MPLS. SD-WAN is not replacing MPLS, but SD-WAN is providing services over SD-WAN, so over MPLS and internet. If you want to go deeper into SD-WAN, just have a look at my videos, my course on that. But overall, to connect multiple branches, we have WAN. In Cisco terminology, the latest solution is SD-WAN. For data center, we have ACI. And if we talk about LAN, we have SD access solution here. As simple as that, right? So Mr. Rahul and Ms. Anjali has explained all of their network, and now they are wondering, can we utilize machine learning here somewhere? So Rahul remembered a problem, right, which is happening so many times. Mr. Rahul is saying that on a particular day, at a particular instance, right, and sometimes this day and instance also gets changed, right? He sees that this MPLS link is overly utilized. Sometimes it is utilized till 100%. And when it happens, right, I do not move to the another link. Why? Because this link has not failed. The meaning of active standby is if active goes down, then we go to the standby. If this link is having high traffic, it doesn't mean it is down, it is right up there. But the problem is it cannot take more traffic. It means that from this here, we are sending too much traffic over this active link. And this link becomes saturated. The meaning is it is utilizing all the bandwidth. And MPLS provider is saying you are sending more than 100. Maybe this link is say 1 Gbps link, 1 gigabit of traffic per second. And now MPLS service provider is saying you are sending me approximately 1.2 Gbps. I am going to chop or I am going to discard the extra 200 Mbps which you are sending me. If that is the case, if service provider is not sending, now the people here start complaining. They are opening the tickets that they are not able to use the application in data center. They are not able to use the internet. They are not able to work. And it is happening. It happened last month also. And Rahul is saying, Anjali, can we do something to prevent this? And Anjali is saying, can you see, I am too confused with all these things, right? Can you explain the problem? So Rahul is saying that yes, I can pinpoint the problem. The problem is exactly over these 2 links, right? Let me take you to the new board right here and explain or zoom into this portion only, right? So believe me, this picture is exactly the same picture as I was showcasing you. This is my Delhi campus. And we have lots and lots of users here, approximately 1,000 users. But we all know that in today's world, some people work and many people work from home and some people come to office, right? Sometimes this ratio becomes that 20% people are coming to office. Sometimes 70%, some days 70% people also come to, and some days maybe 80% are also coming to office. But three days in a week, we receive 20% of the people, means only 200 people come to office, suppose, right? Try to understand when 80% people shows, then this traffic is going to be more here, right? And maybe some of these 80, some of from 800 people, there are some maybe 10 or 20 people which are watching movies, downloading something, downloading a gigantic file, huge file. And what link you are utilizing? You are utilizing this link, MPLS link, right? Its bandwidth is 1 Gbps, although 1 Gbps is a huge bandwidth, by the way. You can have 10 Gbps link, but 10 Gbps link is going to cost you more. So this is the active link, and Rahul explained this problem once again, that over this link, maybe the 0/1 interface of this router, and this router is actually known as your WAN router, which is connected to this WAN, or this is called as WAN edge also, which is connected to MPLS and internet, right? And in some days, some situation, basically this link become 100% utilized, and people start complaining, right? To Rahul and Anjali, they are opening the tickets. So now Anjali is saying that let's figure out this, that why exactly it is happening. Let's think about it. Let's collect some data. Because if we want to solve this problem, what do we exactly want? Rahul is saying it would be great, right? If I get a notice, right? Suppose at 3 a.m. or 3 p.m. that within 1 hour, right now the link utilization is 80%. At 3 p.m. the link utilization is 80%. Anjali is saying it's not a big deal. Any monitoring tool can do that. And Rahul is saying, just wait, let me complete. I want that somebody should inform me that at 3 p.m. the link utilization of this MPLS is 80%, means 1 out of 1000 Mbps, which is 1 Gbps link, 800 Mbps, it is utilized, right? And the same guy is going to tell me, if you don't do anything, this link utilization will be 95% in upcoming 1 hour. This is going to be interesting, right? This can be done by any monitoring tool, right? But this is very, very important. Means if somebody can do that. And Anjali knows this, that through machine learning, we can do this. And Rahul is saying, what? How we can do this? And Anjali is saying, do you remember in machine learning, we are dependent on features and labels, right? Can we discuss few things here? Guys, just wait a minute. Just wait a minute. Yeah. So Anjali was mentioning that this problem can be solved, but we need to figure out some parameters. By the way, guys, am I audible? Can anyone please confirm?
Oh, yeah, you are audible.
Perfect, Sahuji. So Anjali is saying, let's see, can we have the data from the past? For example, when such problems happen, when this link goes to 100% or 95% or 90%, can we see how many users were there in the campus? Or right here, 200 users, 400 users, 600 users, and so many, right? Can we collect this data? Rahul said, yes, of course I can do that, because I have logs for everything whenever this outage happened in past. And I have the normal data also when the outage doesn't happen, right? And then Anjali said that if there is a case, then definitely we know the day at which it happens, the time at which it happens, right? And Rahul said, absolutely. And then, of course, at the time when this outage happened, before that 1 hour, how much basically the link utilization. And Rahul is saying, don't worry about all this information. I can give you everything without any problem, without any doubt. Okay. So here is that information, right? So what I'm doing here, this is exactly the topology, right? And this is the data collected by Rahul and Anjali. And see how Anjali is going to convert this problem into a machine learning problem when we have this data, and how our machine learning model is going to inform us that exactly 1 hour later, when, at which day, which hour, on the basis of the number of users, current utilization, on the time, when this link is going to reach once again over 80%, over 90%, this is going to be told by the machine. How? Try to think what data we are collecting. The day, right? Monday, Tuesday, Wednesday, Thursday, Friday. Hour, what is happening at 10 a.m.? We are recording the data at only 2 hours, right? 10 a.m. and 15 p.m. or maybe 3 p.m. you can say. But I cannot show you all the data. I just want to showcase a few data so that we can understand, right? And where exactly you are going to get this data, we will be talking about exactly from this router. We can get all this data. But how many users were there in that campus when such outage happened? Or basically at 10 a.m., how many users were there? When 350 users were there, what was the utilization of this link? right? When 400 users were there, what was the utilization of the, by the way, we can calculate from the network itself how many users are active at a particular interval of time, because more the user, the more the devices and more the traffic on this link eventually, because every traffic is going on this active link, nothing is going on this backup link, which is standby also, right? So the number of users playing very important role. How you can collect it? You all know that most of the organization is having a TACAC server, or basically a server where all these guys go and connect, give their credentials so that they can connect to your enterprise network. From there, we can calculate exactly at a particular moment how many users are active on the network. So basically all these information, whatever I am writing here, how we are going to calculate this utilization of this link at this particular moment, right? That at this moment it is 40. There are many monitoring tools available which can showcase you that, right? But try to understand the Rahul's demand, right? Rahul is not saying give me the link utilization at 10 a.m., which is 40% with 350 users, which is right here, right? Rahul is not asking about it. We can do it with any monitoring tool, right? There are so many monitoring tools available which can give you exactly at this point what is the link utilization, right? 40%, 30%, 20%, anything, right? They can tell you. But here the ask actually is that can somebody inform me that right now at 10 a.m. the link utilization, or maybe 3 p.m. the link utilization is 70%, and by the time you reach 3:30 or 4, this will be 95%. Then I can take some actions on this information, right? So basically, monitoring tools are helping you to react when the problem has already happened, right? Monitoring tool can tell you right now the link is at 95% or 100% bandwidth. Do some action, but the problem is already happened right there, right? I am interested in one more step. I want to know what is going to happen in next 1 hour. And this is where Anjali is working. Anjali and Rahul has collected all this data from past, and now they are ready for what? Ready to predict. But now consider what are the columns we have. We have days, we have hour, we have users at this hour, means 10 a.m. or 3 p.m. Then we have current utilization at 10 a.m. What is the current utilization of this MPLS link? And then we have next utilization from current to next. What is the meaning? See, right now we have 40, and after 30 minutes or after 1 hour, this is going to be 50, because we have noticed in past that if 350 users are there, right, and current utilization is 40, then most of the time it increased to 50 in just 1 hour. When we have around 400 engineers working, right, and 3 p.m. is the time, current utilization is 70, then there is a high chances, or basically we have noticed through our tools that basically the next utilization is going to be 85%. By the way, this next utilization is the label, or which you must have noticed in starting 11 classes, and all these things are features, by the way. For example, if I talk about salary and number of years of experience, right? This salary was my label and number of years of experience was my input. And you have already, we have already debated many times that the salary cannot be dependent on only numbers of years of experience. And that is why we have another features also. How many certification? What is the age? What is the qualification? Similarly, we have seen the same thing in housing problem also. Size of the house and the price of the house. Size, price. Size of the price of the house is not dependent on the size, maybe number of floors and age of the house and so many other things. Right now it is the same thing. This is X1, my first feature, this is X2, the second feature, this is X3, the third feature, this is X4, the fourth feature, and this is my Y, right? And we all know that if we can give this table to my machine can take all these inputs. What inputs? X1, X2, X3, X4. Machine can take the label also, which is the next utilization. What is going to be happen after 1 hour when we have these inputs, right? And on the basis of that, it is going to calculate 4 weights, W1, W2, W3, and W4, and one bias also. According to this formula, Y is equal to W1x1, W2x2, W3x3, W4x4. So, enjoying learning? If you have reached till this point of the video, I think you are enjoying learning, and I just do not want to waste your time. I would like to say that if you want to see this complete course, this course is available on my website, which is www.bridgewhy.com. Please have a look at it. And along with this course, there are so many other courses available. If you want to start your networking journey from the beginning, from the scratch, or if you are a seasoned networking engineer, please have a look at this website. So you can see here is my website. The link of this website is also available on the description area just below this video. Thank you so much and enjoy learning. Plus B, right? And this is going to be machine prediction. Everything is going to be same. It is to calculate the cost, gradient descent, but eventually machine will give you 4 weights and 1 bias in this case, because we have 4 different features. If these things are confusing you, the meaning is that you haven't gone through the 10 classes. By the way, it is very, very simple if you go through the 10 classes. If we have collected, if we have understood the problem, if we have collected the data, and if we have sorted data, see, your data is not going to be in this form, because when you get this data from here, you have to contact multiple devices. For example, identity services engine to get the number of users. For current utilization, maybe you can use NetFlow. You can use maybe any monitoring device, maybe SNMP. Through SNMP, you can calculate how many packets are going in per second from this. And eventually with that, you can calculate the utilization at a particular moment, right? But if you get this data, if you sort this data into this manner, believe me, calculating after this, creating the machine learning model is very, very easy, right? What we can do this, we have collected the data, right? We all know that we have to feed this data to our machine, all these inputs, X1, X2, X3, X4, and the label, which is next utilization. And then W1, W2, W3, W4 machine is going to give, and Y hat is the machine predicted value, right? Provided the fact that we have run gradient descent, cost, and everything here. This W1, W2, W3, W4, which are the weights and the bias, is calculated using all that differentiation derivative, but to calculate them using a code, it was just 7 lines of code in scikit when we use scikit-learn library, right? So here, if you can see, these are my feature, this is my label, and machine predicted value is this. Machine has calculated all the weights and bias, right? And now if you ask machine that I am talking about a day which is Thursday, and on Thursday 600 users are here at 3 p.m. If you give this machine this data that at 3 p.m. I have 600 users, right? Current utilization of the link is around 79%. What do you think? What is going to happen? And this is basically Thursday. What is going to happen? And machine learning model, if you give all this data to the machine, see, this data is not in this table. The machine is going to predict that if right now this is 79% with this, believe me, in just 1 hour, it is going to be 97%. And it is a problem for you. This is what we want to build, right? This thing is easy. And I'm repeating this once again, that if you want to utilize machine learning, your in networking, your computer networking knowledge should be strong. Your fundamentals, foundation should be strong. Because converting this thing into a code, I can share this code because we have run this code many times in our starting 11 classes. Calculate. See, I am using the scikit-learn library. I'm using pandas, right? This is my data. I haven't written the full data, but you can write the full data. This is my input. This is my label. And I am training the model. I'm using linear regression. Linear regression from where? From scikit-learn library. And I'm saying fit, model fit X and Y. It means that what is the meaning? The meaning is this line, this single line is going to give me 4 weights, W1, W2, W3, and W4, and B also. And then I am going to give the program a sample that what is going to happen at 3 p.m. when 500 users are there and current link utilization is 73%, maybe the machine is going to say in another 1 hour or half an hour, it is going to be 85%, because whatever the data I have feed to the machine, it is not the case that this is going to be 100% correct, but machine is calculated this 85%. Why? because based on your previous data, the table, right, it is saying that it's going to be 85% in another 1 hour. It is not guessing. This is based on that particular data which you have fed into the machine. And then you can do the logic. If predicted utilization is 80%, which is more than, if it is more than 80%, we can say high utilization predicted shift traffic to the backup link. And that is where your means you can automate this process, that if MPLS link is having more than 85%, or if machine is suggested that it is more than 80%, it is going to happen, then we will be shifting some of the traffic to internet, maybe 20% traffic to the internet. As simple as that, right? But what you need to tell the machine, what you need to study, what you need to think, you need to tell the machine that this is a problem, this is not a classification problem, this is a regression problem. Why? Because from 1 to 100, you want to, this is a number, means huge numbers are between 1s and 100. And over this link, you have to tell me that how much it is going to be after 1 hour of all these values. Then you have to tell 85%, 86%. You have to calculate or anticipate a number out of these 100 numbers. And when we are anticipating this number, when we are trying to predict the number out of many numbers, then this problem is known as the regression problem, right? It is fitting the linear regression. That is why you tell that the model is y is equal to w1 x1 w2 x2 and so on, right? And machine gave you the values of w and b, and that is it. Guys, if you have any doubt, any question till this moment, you can ask, or at least please tell me whether you are able to understand, or basically, am I audible? Anybody? Am I audible, guys?
Yes, sure.
Yes.
Perfect. Thank you so much. Now, let's talk about another problem, right? So one problem we have discussed, where we have spent a lot of time, and which is the linear regression problem. In yesterday class, I introduced classification problem. The meaning of classification problem is, now machine need to predict or tell that whether a student who has learned only 5 hours, it is going to pass or fail. Machine need to tell the category pass or fail. Maybe an email which comes to you, is it a spam mail or a normal email? These kind of problem comes under classification problem, and classification problems is also known as logistic regression. That was linear regression. This is logistic regression. But why regression again? It's a historical, the naming logistic regression comes from the history. I do not want to go into that. But if you are uncomfortable using logistic regression, just call it classification. We introduced it yesterday. When machine has to predict only the classes pass, fail, 0, 1, spam, not spam, fraudulent, not fraudulent, it is going to be tumor or not, right? Then basically it is classification. When it predicts a number out of many numbers, it is the regression problem. Now, Anjali has figured out one more problem into this network. Anjali is saying that, see, our business, Sports India business, is totally dependent on the server we have put on the Mumbai data center. And basically, just wait a minute, guys. 1 minute. Yeah, connection restored. So this server basically is hosting Sports India website, where this Sports India actually sells lots and lots of items, cricket bat, cricket ball, and so many things. And people around the world which are sitting on this internet, they come to this server, right? And they order online so that the goods can be delivered to their places, right? But Anjali noticed one thing, that during festival season and some other seasons, right? Sometime the servers goes down. Means during that period, maybe when the World Cup is there, or any sporting uh, big event is there, when people buy more, then the server goes down, and total business of the Sports India Corporation is depending on the server. Why the server goes down? Because on internet, it is not the case always that only the legitimate users are there. There are some users which are in this red color, right? They are there only to destroy your business. But why do they want to do that? They want to do this so that you can give money to them. Do not destroy my network and have some ransom from me, right? Interesting. So Anjali noticed that during that period, this server just goes down. We have put another server also, but there are some attacks which make this server so that the server is denying its services. What is the service of the server? To offer Sports India website. If it is not showing Sports India website to the users on internet and they are not able to buy things there, it means that it is a denial of service. And who is doing that? This red guy is doing the denial of service attack. We will talk about what is the meaning of denial of service. But Anjali has a specific problem and she's asking to Rahul, can we solve this problem using machine learning? Right? And Rahul is thinking about that. Yes, we can solve. It means that whenever it happens, right? And Rahul is now brainstorming on this problem to understand what exactly going on during that period, right? So what I have done here is, by the way, this session is a little bit networking heavy also along with the machine. I am presuming that machine learning 10 classes we have in our pocket, and then we are implementing it into the network, and that is why networking knowledge should be there. So now we have this Mumbai data center, and this is the server where Sports India website is located. So Rahul is very good with respect to security things, security understanding, network security. And he's a security engineer also in the same organization, by the way, right? And Mr. Rahul is saying that I am going to figure out that what exactly had happened. So he has calculated all the logs, collecting the data, that what exactly was happening. So there, in that period when the attack happened last time, there is one event happened, maybe the Cricket or Football World Cup, and many people are buying things from this Sports India website. The sporting goods they are buying, right? There are maybe say thousands of users which are legitimate users. They are coming via internet. They are reaching to the data center and the service Sports India website. They are ordering and they are getting their stuff, right? Happily. But the same day, this guy is also sending or initiating a connection. I am denoting it with the red color, right? To make this connection, to open this website, we need to make a TCP connection. We all know. And how we start the TCP connection? With simple SYN message. This is my SYN message. What server is going to do? Server is going to reply with SYN plus ACK. The meaning is, I am acknowledging your SYN, and this is my SYN towards you. This is the second step of three-way handshake. First step is sending the SYN. But after that, this user doesn't send anything. And you must be wondering, that's fine. But the server is waiting, by the way, right? The server is having some resources which is waiting for acknowledgement to come back, which is the third step, but it never came back. And suppose it happens with many other users also. I mean, there are many other users which are controlled by this guy. By the way, these are not users, these are the bots. These are the computers controlled by this guy. And every computer is sending, there are thousands or maybe lakhs of computers which are sending only and only SYN message, by the way, right? Server is sending SYN ACK back, but this guy is not sending ACK. This guy is not initiating the connection. It means that server is busy in maintaining the record of the SYN, right? This is the vulnerability in the TCP, that the server can't close this connection. It is expecting the SYN acknowledgement back. And most of the server resources are going into the maintaining these thousands or lakhs of pieces or SYN messages, right? That is where server gets overloaded and it is stops, right? 100% utilization of server is there, and then it is stopped working, right? And this is basically denial of service. What was the server doing? It was offering website, but now it is not visible to user because the server is hanged, right? This is the denial of service attack. But the important piece about this SYN message is, and by the way, there are other ICMP fraud attack, or there are so many fraud attacks, denial of service attacks, right? If we talk about this specific attack, these guys are sending lakhs of SYN messages from different bots. What is the SYN message? SYN message doesn't have data, by the way, right? If that is the case, this message is going to be small, no data, right? Maybe 40 bytes, 50 bytes, 60 byte message, right? So Rahul is doing all this research and came to know that whenever these attacks happen, the router of the firewall, which is connected right here on this interface, which is connected to the internet, basically it is getting many small packets. And the packet rate has increased too much. Means previously in normal times when only 50 packets per second comes, and this packet is of average size of maybe 800 bytes. This is the normal time, right? But in such times, maybe 1500 packets per second is received by this firewall, right? And then the average packet size was only maybe say 90. If that is the case, there is a problem, right? We can figure it out that somebody is sending a lot of messages, right? A lot of small messages. It's a problem. So Rahul is saying, I got the issue. And I got when it happens. I have differentiated the traffic. Rahul is a security engineer also. He is not interested in a particular packet. He is interested in a flow. What is the meaning of flow? Flow means a packet with the same source IP, same destination IP, right? Source port, destination port, and protocol. And now he can understand. We can see inside this packet which protocol, TCP, UDP, anything, right? We all know about these things. But if you don't know, that is perfectly fine. But I'm again repeating this thing. If you want to utilize your machine learning knowledge, you are into networking, your networking fundamentals, foundation should be strong, right? And now this problem, right? Rahul is saying, I can do one thing, Anjali. I can generate a machine learning model which can tell me by seeing the messages how many packets per second I have, right? What type of message I have, TCP, UDP, what is the size of those messages or packets. If I get all these details, my machine learning model is going to say that now the traffic, whatever you are receiving, it is a normal, not a normal traffic. This is an attack. Or if there is no attack, then it is going to say normal. Nothing to worry. Only two categories your machine need to predict, whether it's an attack or it's normal. And this means that this is part of my classification problem. I can denote attack with 1, normal with 0. Or maybe you can interchange them. That is perfectly fine. 0 or 1, 1 or 0, as simple as that, right? This classification problem, by the way, we discussed in the last class. Okay? And it is again very easy. So in the next board, what I would like to showcase you that how I am going to do this. I will be connecting all this information, packet rate. What is the meaning of packet rate? Maybe 1 second, 10 seconds, how many packets are there on the interface? Which interface? Maybe the firewall or the router which is connected to internet and from where the internet traffic was coming towards your data center, right? This may be the router or maybe the firewall, depending on whatever, how you have designed, right? But from where you are going to collect this traffic from this router itself, it is going to tell you what is the packet rate on this interface. Or maybe you can receive, you can get what are the number of packets in 1 second received on this interface, right? You are going to get this packet rate, as simple as that. What is the average byte? You are going to take 100 packets, calculate the number of bytes in them, and divide by them 100. Then it is going to give you the average packet size, right? We are interested in that, by the way, because if it is a small, then there are going to be so many SIN packets or so many small packets. Then we are collecting the information from the packet itself, which is the protocol. Means every packet is having the protocol field, which is TCP or UDP, right? Or other protocols, right? And then from the past thing, we can see that whether this was the attack or not. This is the past data, by the way. This we have to feed to the machine, and machine is going to predict for the data points which are not in the table. This is what we have been doing, right? Predicting the salary which was not in the table. Predicting the student that whether if he has learned 6 hours, whether it's going to fail or pass, right? Interesting. It is saying that, see where it is 1. It is saying 100 packets, average byte is 100, small packets, so many packets. Attack has happened, right? 300 packets, average bytes 50, attack has happened. TCP protocol. By the way, I am just giving you an idea. This inputs can be really more, right? So what these are X1, X2, X3. What is this? This is my actual label. In yesterday class, we started with this Z, right? And we feed this Z into the sigmoid function. And people got confused here. That is perfectly fine. What do we want to do? Because this is a classification problem. We do not want to come across a number. We just want to know whether this is an attack means 0. Sorry, whether this is not an attack or whether this is an attack, right? So sigmoid function, we start with the line which can have minus infinite to infinite. It is not between 0 and 1. Sigmoid function just compress this into the graph like this, right? Simple, between 0 and 1. Interesting. So overall, If we use this classification, if we use this model, machine is going to tell us whether it's an attack or not for those values also which are not in this table. And this is the whole sole purpose of machine learning. Machine learning is not reactive. It is expecting that if packet size is almost this one, if this information is this thing, then I can say that this is an attack or attack is going to happen in future. Because right now, if you see the 100 packets, pretty soon it is going to be 1000 or 1 lakh packet, maybe within seconds or maybe within some minutes. You have this window of maybe 5 minutes, maybe 1 minute, maybe 2 minutes to work on this. Because if we get the information that attack is starting, or attack has just started, we can just tell to the server that is just free the memory you are waiting, because that memory is just, or basically we can do so many preventive things, right? So this is the overall how the classification problem are done, right? I think we all are on the same page with respect to this. Now, the code is again few lines of code. I will be sharing this Google Colab file with you. Don't worry about it. I have run it. It's very, very easy. And by the way, we have run such kind of code many times in this course itself. As I mentioned, coding is going to be easy. Understanding what this code is doing is a little bit tricky, but now we understood it. Again, I am using Panda library. I am using scikit-learn, right? And this time I am using logistic regression. What is logistic regression? It is classification problems. It gives me whether it's an attack or not an attack. So this is my data, by the way, right? And I am using model this time, logistic regression. I'm just fitting it right here. Okay. And then I am testing with the sample, because what it is going to give me, this is going to give me the weights, W1, W2, W3, and then the B. And now I have the weights, I can predict anything. And now I am giving it that the packets per second is 120, packet size, average size is 90, and the protocol is say 1, maybe this TCP, suppose, right? And the model is saying attack, because we have lots of small packet coming here, right? Based on the data, as simple as that. Don't worry, I will be putting all this file, Google Colab file, in along with the classes itself, right? So now, if you guys have any doubt, any question, please do ask. But I don't see a hand raise. So let's talk about another topic. By the way, I'm not going to explain the mathematics, but this is what I haven't told you in the last class. See, what is the entire process of machine learning? First, we have to deal with data. We have to sort this data. We have to figure out what are the inputs, what is my label. And these two things are very important in supervised learning. So by the way, what we are learning, machine learning has different types: supervised, unsupervised, reinforcement learning. We are not talking about unsupervised or reinforcement. We are just talking about supervised. Inside supervised, we have two things. We have linear regression and we have classification, right? So it all started with the data. So I'm explaining the complete process, inputs and labels. We give inputs and label to the machine. Machine has to calculate the weights. Based on if we have 4 features, it is going to give me 4 weights and 1 bias. And how we are going to get this weights and bias, based on cost function and based on my gradient descent algorithm. Irrespective of the fact I'm doing problem with respect to classification or linear regression, this process is going to be same. But this cost function can be different. The model in linear regression, we use W is equal to WX plus P. In machine learning, in classification, we have used y is equal to 1 upon 1 plus e to the power minus x, where x is wx plus p. This was basically my sigmoid function. If you don't know about it, that is perfectly fine. You can leave it there, right? But again, the process is going to be exactly same in the classification. We will start from the inputs and label. Here in the case, the input was packet per second, right? The protocol itself, and basically the average packet size. That is why machine is going to calculate W1, W2, and W3. 3 features, 3 Ws, and 1 bias. How it is going to calculate on the basis of cost. And for this function, previously for the line, we have linearity. But we have broken the linearity because we have compressed this line to this sigmoid function. Now this is not linear. This is something else. And if it's something else, it is not creating the cost versus W graph like this. And we were anticipating such kind of graph because we want to reach the bottom of the bowl. if all these things looks alien to you, means that you haven't uh, seen my classes 8 class, 9 class, and 10 class, where I discuss derivative, this bowl, and everything, right, in detail. For classification thing, we have to change the cost function. Previously, the cost function was 1 by 2m, right? And this is the problem. If I have written the same thing in the first class, you must have said, Vishnu, whatever you have written means we don't get it anything, right? And that is why I have explained the cost in case of linear regression, which was 1 by 2m, sigma I is equal to 0 to m, yi minus y hat whole square, right? I have explained this in 5th class, by the way. First, we understood sigma. What is y hat? What is this? And that's why you got so habitual about it. You got so habitual about the derivative and gradient descent also. But in case of classification, if I explain this again, I need another 5 classes. And I am saying that you do not need to learn every mathematics with every problem, right? What is the whole sole purpose of explaining that mathematics? So that you can understand this complete process. We have data, we have input and label, we give it to the machine calculates the weight using cost and gradient descent. That is it. This formula can be changed. Y is equal to Wx plus P chain can be the sigmoid function. Cost can be changed. Right now for the linear regression, cost is this. For classification, cost is this. From where it is come, it is all mathematics. By the way, if you understand the log, you can understand it very easily. I have understood it. I have just spent maybe 2 hours in that. You can do that very easily. But the question is, do we need to do it? No, absolutely not. Because you have already understood the code is actually this one, right? And I can understand what exactly this code is doing, right? We do not need to understand each and everything in mathematics. Maybe if you want, I will be available on WhatsApp. If you really want to understand this, definitely, right? We can talk. I can come on the meeting, maybe any Teams meeting, and I can open the whiteboard. We can discuss, we can have a discussion if you would like to do that. By the way, guys, this is what in my mind for this class, right? Now the question arises, what is next? What we are going to do next? This course is over, by the way. But now you can start your journey in deep learning. I can come up with a course on deep learning for sure, but is it going to be useful? Right now, what I am seeing in my daily life, that we are moving away from your normal work. Everybody is saying automation, code, AI, ML is going to come in this field very soon, right? If you say, I know foundations of networking very well, I know a little bit automation, I know SD-WAN, I know SDXs, some little bit of security also. Company is going to say, okay, that's fine, maybe in next 6 months. But can you implement a customer network using SD-WAN technology? And you are going to say, absolutely, I can design the network. LLD, HLD, you can say anything, I will write it. But then can you implement is, see, we do not have 6 months. Can you implement the project in maybe say 30 days? And you are habitual about of having long maintenance windows, right? If the customer is having 100 sites, there might be maybe 2 or 3 maintenance windows over the weekend, right? It is a very slow process. Company doesn't want it, right? And believe me, that is why many of the companies are coming up with another approach of creating the network. For example, in case of SD-WAN, what is the general approach? You go to the customer, you collect the customer requirements. Then, on the basis of this requirement, customer is decided they want to go ahead with SD-WAN. You collect the requirements. Then what you are going to do? You are going to create the high-level design document. Customer is going to agree. Then you are going to create the low-level design document, and then you are going to create the NIP, network implementation plans. Then basically you are going to test. This NIP is for maybe if the customer is having 100 branches, 2 data center, 2 campus, you have to write the NIP for everything, right? Some people use automation there, but how you are going to implement it? You are going to open the UI of the controller if you are aware of the SD-WAN, and then you click here. But believe me, this click approach is something. See, previously we used everything on command line. Then they said, no, command line is bad. Just come to the GUI part. That is why we develop these controllers, graphical user interface. And now everybody's saying, no, 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 this is slow process. Why don't we go again and do this with this code, right? So you define the topology in the code itself. You do not, by the way, for that, you do not need to learn the code, but something in the middle of the code and human you need to learn, right? Every network engineer can define what kind of topology he wants on the basis of this HLD and LLD, right? And then your computer is going to create, you do not need to click on this graphical user interface. Basically, your code is going to create that entire topology. If you have this file right, the network implementation plan is going to be very easy using code, right? And the margin of error, because if human is doing the thing, the margin of error are more, right? But here, you have planned the network well, you have written this code, and after that, it is going to be just pushing that code into the devices itself, right? And by the way, this approach is actually known as, if we are doing software defined creating SD-WAN network, then it becomes SD-WAN as a code. So this as a code, right, is pushed by every company. Basically, in my company, I work for Cisco. Believe me, the upcoming projects which are coming, it is not going to be this way that I am going to open the UI, creating the NIP and everything, right? No. Basically, they want everything to be done by as quickly as possible, error free also. That is why SD-WAN as a code, ACI as a code, and other thing as a code are coming, and it is going to be everywhere. Believe me, right? So in this small time, whatever the time we have, I couldn't explain many things, but there is going to be webinars soon on as a code feature, right? And if you all agree with me, if you see that this thing is coming in future, definitely we will be having a course around as a code, maybe SD-WAN as a code to begin with. Thank you so much, Mr. DK, for asking a question. Please go ahead. And by the way, now the course is complete. Any question, whatever is coming to your mind, please do ask. Anybody, please?
Yes, sir. Hi, sir. There we go.
Yeah.
So, like, just to be ready for this in the future, like, what should be our skill set to be with? Like, we know that we know SD-WAN or we know the ACI, but what should be like excel in the Python to learn these skills, or what should be our weapon for all these things?
Yeah. For this as a code thing, basically, see, right now, we are saying that we are network engineers. We are not interested in writing code for sure, right? But company is
Yes.
saying use as a code. So there is a middleman, right? What is coming? There is somebody who is kind of a robot here, which is known as, by the way, Terraform, but leave the naming. This guy is very good, right? On one hand, it can write the code by understanding another file, which is not a code. If this is not a code, this can be understood by any network engineer. And these files are maybe YAML or XML or so many things, right? So what network engineer is going to do? He's not going to open the UI. He's going to create this XML or YAML file. He is going to write all the things here. What this robot is going to do, he's going to take all, he understand this YAML also, and he understand this code. So what he's going to do, he will be converting whatever you are writing into this code, and then it will be pushed to this vmanage, or basically your controller. This controller will be executing this code, right? And whatever you used to do with clicks, you just need to write this file. As simple as that, right? So the extra skill you need to do is this YAML, because understanding Terraform and how it works, basically it is also very simple though. But this is the, and by the way, I have explained YAML, XML in my automation class. So this is going to be the future of creating networks, how basically we are going to create network fast using SD-WAN, ACI, or maybe any other thing. This is as a code, by the way. Anybody, any doubt, any question? Sangeeta ji, I think you had a question you were asking in the beginning. Please do ask now. Now is the time. Because this class, this course is finished. And one thing I would like to mention here is, if anybody you think that this course was something, I was expecting something else, Vishnu has not fulfilled whatever he's promised, just give me a call and we will make sure that you will get back your money back, right? Because if you have spent your 12, 13 hours with me, right? And if you haven't got anything, or if you have some issues with that, please talk to me, right? Sangeeta ji, are you there? If you are there, please do ask your question.
Yes.
Yeah.
Yeah. Actually, in Hindi class, as you told, like I think in English class as well, like if our traffic is on MPLS and if there is like 100% utilization or MPLS network is exhausted, so we can migrate our traffic to internet. But on MPLS, like that is private and there is performance, we are getting best performance. So how can we migrate to internet because there won't be any security or performance also be degraded? So that's why I wanna ask, like, can we do like that?
Yes, even basically in most of the organization we do that. See what is happening here. This is our MPLS router of this campus network, right? It has two links, and basically one is connected to private service provider. And by the way, this is very good question. And then we have internet here, right? The question is basically
Yeah.
we have the data center and we have server, internal server also, maybe our HRMS or HR related system and everything. The private property is there, right?
Right.
But we connect this to internet also, right?
Yeah.
Our
Yeah.
data center. Now the question arises that you are saying that this here is somebody who is the employee here, right? And he is accessing this server. So the traffic flow looks like this. He will be going like this MPLS router, right? Or basically not MPLS router. This is my WAN edge router,
Yeah.
right? So the traffic will go like this over MPLS and this thing. Now the question
Right.
arises, Mr. Vishnu, if this is 100% blocked or if it's 100% utilized, how you are saying that this can be go into the internet? Don't you think that internet is full of those people and this traffic can be seen by many, right?
Right.
Hackers are
Yeah.
there.
Mm-hmm.
If this is an MPLS network, then it's not a problem because it's a private network built by
Yeah.
Airtel, right? So nobody can come in.
Right.
It's a genuine question. But now try to understand. When we send something on internet, it is not in the plain form,
Mm-hmm.
right? And that is where VPN, virtual private networks, come into picture. One of such technology is IPsec, right?
Right. Mm-hmm.
So basically, we just not send this traffic like this, means source IP, destination IP, and then our data. What we do, we encrypt our data first, right? And then this encrypted data is known as IPsec tunnel. We form this IPsec tunnel, which I'm going to showcase you between one router is going to be here, and this tunnel is formed between this and this. So if somebody is carrying these packets are going to be encrypted. So sorry for that.
Okay, I was thinking like that will go in plain format. Oh, it's yeah, okay, it's fine. If that is going via VPN and then IP security is enabled, okay, then it's fine. Yeah.
This is what SD-WAN is also doing, right? They are creating these IPsec tunnels only, and previously also the
Right.
DMVPN, which is the WAN technology.
Yes.
See, I 100% agree with you that I don't talk about the security, right?
Yeah.
But it is if you're sending anything over internet and say corporate data, it is going like this.
Mm-hmm. Right.
Okay.
Right. Absolutely. Yeah.
Perfect.
Thank you.
Anybody else? Anyone? Any other question? I think we all are good. Okay, we have a question from Sumit Sharma ji. Please, Sumit ji, please do ask a question.
Sir. Hello, sir. My question is, like, since we have finished this course with respect to ML, right? So, just want to know, like, with the hype we have for AI as a network engineer, what should be the next step and how to go ahead with that?
I would say that this is one of the important piece which you have now in your belt, machine learning, right? I would say let's learn a bit about deep learning also, because this is our first step in getting into the world, what is going on, like chat GPT, how it is working, large language model, and so many things, right? And that is why I'm so confused that right now the demand in networking industry is as a code, which I talked about, right? It is going to be soon. Because if Cisco, Juniper, and other companies are into this race now, for example, how we all learn networking. The reason is Cisco and Juniper and other companies created these routers, right? And they have placed these routers everywhere. If nobody knows these routers, then who is going to do the fix or anything, right? That is why we learn computer networking. Now, the question is, even these routers are getting changed. Now, instead of this router, we are having controllers, right? On controllers, we need to perform multiple action. And now they are saying perform those action using these YAML files and so many other things, right? If we have started this thing, it is going to be in mainstream pretty soon. What we want to do, Definitely deep learning is not a problem. It's another 11, 12 classes, you would be okay with respect to deep learning, just like machine learning. And I'm 100% sure if anybody is sitting here, just see these 11, 12 classes. You will be good in machine learning. I'm not saying you will be good in every aspect of machine learning, because one of the aspects is cleaning of data, which I haven't told you how to do that. That is part of data science. You can learn about it. But similarly, we can talk about deep learning, so that you would be good, and maybe whenever there is a talk of doing some AI, machine learning, deep learning projects in your company, you can say, I know well. And you must have seen these two examples in today's class where we are connected machine learning with networking, right? Only the network engineer who knows the foundations, fundamentals, and those fundamentals should be strong, then he can participate in machine learning, right? So the right path is learn a bit about deep learning also. But along with that, if you want to be relevant in longer term in this field, learn as a code also, right? That is why I was planning to do segment routing course, ACI course, right? But I am again keeping them, I will push them again to cover first as a code and DL. But before that, I will be doing a webinar on these two topics, by the way. And whatever you say, whatever your votes are, we will be taking that course. Okay, Sumitji, is it helping?
Yes, sir. So and the other question is with respect to ML, we are good. I mean, with the thing we have now, and we can just revise and maybe make them into our memory. I mean, into our daily practice or something like that, so that we are not forgetting these concepts. And for the next part, we can learn the deep learning.
Yes.
Then it should be okay for the part we are doing with respect to the network.
Yes.
We are supporting. Okay.
Correct. Anybody else? Any other question?
So
Anything
will
which is
you
coming to
take
your
the
mind?
deep learning classes as well?
I'm not sure. That's what I'm confused. See, demand right now is as a code. Believe me, the demand is basically in my company. If people are not learning this, then there is a specific thing
Actually,
they
a
are saying.
lot
Yeah.
of people nowadays talk about LLM model. So everywhere that is prevalent. Like a lot of persons are talking about like deep learning because we just learned about supervised learning only. Like there is unsupervised and there is lot of more. If I'm just hearing to like a few guys, then they are talking about all these things. So we know like linear and classification, but I think that is only one part.
Yes,
So I think.
I know that
Mm,
that's a completely another branch, because deep learning is based on neurons, and you will be amazed to learn these concepts.
yeah.
But right
Mhm.
now, whatever going, because I know that there are some companies which actually what we can say, which show the path to network engineer, the company Cisco, Juniper, Arista, right?
Mhm.
These
Yeah.
companies, how they are delivering, how they are creating network for their customers, it is
Mhm.
now based on as a code, and it is very uh, means in last 6 days you won't believe I have been noticing all this thing, right? So I am a bit confused. You are right that the next course should be on deep learning, but if I see things around, as a code is another very important thing. So let's see, we can do them together or maybe one by one, but we will be doing between DL or as a code. I will be letting you know.
So if you
Okay.
don't want to take like a lot of classes, so you can take few classes so that we can be just aware about deep learning, then immediately you can start like AAC. So one thing here,
Good
like
suggestion. Good suggestion,
yeah,
by the way. Yeah.
yes, short classes for deep learning, then you can concentrate more on like as a code. So nowadays, like if I'm also observing, like a lot of people are using Ansible. So all those scripts are written in YAML, right?
Yeah.
And if we just talk about Terraform as well, so I think a lot of people can use those. So in as you were talking about SD-WAN as a code, so something is different is happening in that or
Yeah, a
how?
bit a pipeline concept is there, and that is why I would like to take almost 1.5 or 1 hour to explain what
Mhm.
exactly it is, right? So don't worry, we will
A
be taking a
pipeline,
webinar
it's
on.
been like that is automated thing, na? Like in pipeline,
100%,
like.
it was everything was there. We are just taking, see, it was there in software engineering for
Like
so long.
DevOps in
Yes,
engineer.
it was there.
Okay.
It was there in software engineering for quite long. But for network engineers
Mhm.
like us, the pipeline,
Uh-huh.
the Terraform, Ansible,
Yeah.
everything is new,
Yes.
right? So
Yeah.
give me couple of means maybe couple of weeks, and I will be coming up with a webinar for sure, Sangeeta ji.
Please before like that take deep learning classes so that we can be aware because we can continue in the perspective of AI.
Yeah, I will consider definitely this thing also. It's a nice suggestion.
Okay.
Yeah, actually, I'm also thinking if we can continue with the deep learning, then for us, AI should be at least completed
Okay,
before we can jump into the infrastructure as a code or maybe self-driven as a code.
Good.
Whatever.
Definitely, I will
Yes,
do a poll with the 150 people for sure as a code. I will give a brief introduction. I will give, and definitely, and actually, if you ask, deep learning is my choice, but what market is asking as a code. So I am a bit confused. Just give me some time. I will figure it out. Okay.
Then we can combine for both of them in that case.
Yeah.
One class for this and one.
No,
Yeah.
not exactly like this, but maybe starting 5-10 classes for deep learning
Yeah.
and then
Right.
No, I got the
continue
point.
with the.
I got the point. Thank you so
Yeah,
much.
because I
And
remember you did a course like this only where you told us this BGP, OSPF, and MPLS both. I mean, all of the things together,
in
right?
combined,
Although
yeah,
the core, yeah, although the course was long, but yeah, that was a good course.
yeah, yeah, yeah. I will definitely take your suggestions. Thank you so much. Anyone has any doubt, any question, means you can ask anything. Okay, so I think we are good. I would say again, thank you so much. I have learned a lot from your questions. Thank you so much for your patience. Thank you so much for being with me from last 2 months. And thank you so much for your lovely emojis. See you in some other
In
course.
fact,
Bye
we
for now.
should say like thanks to you a lot. Like we learned a lot from you, and in so like layman language, like we never ever expected. Like we can learn in so easy language all these machine learning concepts. Really, thanks a ton for this.
Yeah, thanks
You are
again
most
for the
welcome.
such a lovable course again. So we are into a habit where we can learn anything with while we are connected with you.
Thank you so
That I
much.
can say.
Thank you so much. Thank you so much, Sumit.
Yeah.
Thank you so much, Sangeeta
Thanks,
ji.
Vishnu. Yeah, it was cool. Thanks.
Thank you so much. So see you guys. See you soon. Bye for now.
Thank
Thank you.
you. Bye bye.
Thank you. Thank you, Vishnu.
Thank you.